Okay, so the definition of pressure that we did was that pressure was force per unit area. Okay, because we know the formula for pressure, pressure equals force over area. So pressure is force per unit area. However, we have to think about different situations. What directions of force applied and how does that force look if we draw a diagram. So let's say we have a flat surface and we apply a force to that surface. That surface has an area. So this whole surface itself will have some kind of surface area. It will be obviously maybe a rectangular surface or a circular surface or whatever. We have some kind of area and we apply a force onto that surface. That force will normally be applied down the way, some kind of force. If it's the weight of the object, it's just the weight of the object pushing down on the surface. Now, what we have to be careful of is what direction the force is applied. So the force must be applied for the formula to work at right angles. Now how we can write that in a few different ways. We can say that this is tangent to the surface. We can also write normal to the surface. All these things, right angles, at a tangent, at a normal to the surface. So what we might have is we might have a situation where we don't actually have a force that's at normal to the surface. We might have one that's at an angle to the surface. So let's say we have our surface again, and we have a force being applied at an angle. Then that force itself has two components. It has a force pushing in that way, and it's going to have a force pushing in that way as well. It's going to have two components to the force. So this is going to be the force in the vertical direction, and you'd also have a force in your horizontal direction. So you must take into account the force in the vertical direction. So we work out our angles, we work out what that force is. If we could draw a triangle for that, we'd have a triangle, that one there, and that one there, right angle triangle. Say this example here is angle X, that would be angle X, and there, this would be F, and we could work out, this would be F sine X. So that would be the component we were interested in. We'd interested in the component that's at a tangent, or right angles, or at a normal to the surface. That must be the force that we use. We can't use any other force. Okay, so this would be, heading can be choosing the right force. And copy this down, please. So choosing the right force. Make sure you choose the right force when you're applying for a pressure diagram.